Imagine a reality beyond our own, a realm where the laws of physics bend, and the possibilities are even vaster than the cosmos itself. Now imagine that you could not only go there, but that you could move through it with ease. Welcome back to our channel, and today we're answering the extraordinary question, is interdimensional travel possible? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Everything But What for more clips like this one? And ring the bell for more thought-provoking content. Interdimensional travel is one of those unusual concepts that has seriously changed shape and focus in recent times. Not so long ago, even mentioning it would have led others to thinking that you were either a science fiction writer wholly wrapped up in your latest idea, or a paranoid conspiracy theorist hell-bent on believing that nothing is real. Now, however, times have changed, and interdimensional travel clearly isn't the kooky, out there, really kinda questionable prospect that it once was. Instead, it's a genuine source for scientific consideration. Today, we're setting out to unravel the enigma of interdimensional travel, what exactly it is, and just how feasible it might be. We'll also be taking a closer look at proposed technologies that might one day allow us to achieve it, and we're gonna explore what our lives would be like if it ever were possible. The enduring mystique of interdimensional travel is all to do with what it fundamentally would offer to us, a way to break out of not only this world, but this plane of existence. At its simplest, it refers to the hypothetical ability to move between different dimensions or realities beyond our own. To slip into a total unknown. And, although we do usually understand different dimensions as being some kind of extension to the three spatial that we already know and experience, in this context, a dimension could really be any independent realm with its own set of physical laws and properties. It's an idea that certainly draws inspiration from some major theories in physics, such as string theory and the various multiverse hypotheses, where it's proposed that our universe is just one of many, but interdimensional travel is also hugely flexible. From some points of view, there aren't actually a great many rules to abide by. Nevertheless, to travel to another dimension would always imply somehow traversing the boundaries that separate these distinct realms. And, in short, that would require an understanding and mastery of forces and energies that are beyond our current comprehension. Even if we did stick to the most straightforward proposals for extra-spatial dimensions, knowing how we'd break into a 5 or 60 realm is something that's currently beyond us. So, the fact is that, as of now, to interdimensionally travel is to remain firmly within the territory of science fiction. At a point in time when we still don't even understand the majority of the fabric of just our own, standard universe, with dark matter and energy being used to explain away our many, massive blind spots, we just don't have the technological prowess needed to manipulate and navigate between dimensions. But that's not to say that we never will. When debating the possibilities that might unfold, there's really only one place to start: wormholes. On one level, these are hypothetical tunnels through space-time that could connect distant points in the universe, allowing us to instantly move to where would otherwise be light years away from us. And that's already pretty far out and impressive. But on another, higher level, wormholes could offer even more. They could potentially link us to different dimensions. Wormholes are essentially cosmic shortcuts, allowing for faster than light travel and therefore dramatically reducing the time needed for all physically imaginable journeys. There is one major hitch, though. While they're theorized and do work as per our current scientific understanding, we haven't yet created or discovered a wormhole in real life. So, that would need to happen first. And, even then, there's certainly no guarantee that wormhole travel would work quite as seamlessly as it always does in the movies. To stabilize a wormhole and keep it open, we'd require exotic matter with negative energy density. Known as exotic, because it violates the energy conditions of classical physics, it's also purely speculative at this point. And so, while again the math behind wormholes is theoretically sound, the practical challenges and the unknown properties of the matter needed to make them work are why this still isn't an approach that we can in any way rely on. Theoretical physicists continue to explore what's possible, but right now wormholes really are story rather than fact. Nevertheless, all perhaps isn't lost. Inspired by the warp drives of science fiction, the Alcubierre drive is another theoretical model that seemingly would allow us to break into new dimensions, if they do exist. Only, this time, it's a concept with just a little more meat to the bone. An Alcubierre drive proposes the manipulation of space-time to again reach faster than light travel. Specifically, it involves contracting space-time in front of a spacecraft and expanding it behind, creating a warp bubble that then carries the vessel along, locally free of physical constraints. Inside that warp bubble you could basically do anything. It's as though you'd be closed off from this reality, and no longer held back by the standard laws of nature. Here, there have been genuine designs created, as well, and even rumors of a working prototype, although nothing has yet to be officially announced or demonstrated. The main problem is that, once more, it's thought that it would demand enormous amounts of exotic matter with negative energy density to warp space-time via the Alcubierre method. All of which means that it's also not currently conceivable, even if the idea is less vague than simply wormholes. Finally, though, and if modern science has taught us anything, it's that the answers might be found if you target the world of the very small. In this way, researchers have more recently looked to quantum entanglement to bridge the gap. This is a phenomenon where subatomic particles become interconnected, regardless of the distance between them. In just this universe and dimension, they might exist millions of light years away from each other, but would still be inescapably bound. And it's this degree of unbreakable bond that has gotten some thinking. Could entangled particles be used to create connections not just across super long distances but between different dimensions? Here, it appears as though we wouldn't need the great unknown of exotic matter to make it work. Although to understand and control entanglement on a large scale we would need some major, as yet unforeseen advancements in quantum technology. In another recent video, we took a closer look at how quantum computing works, and it could be that the machines and qubits of the future will eventually provide us with the power required. Although, quite how is still seriously vague and entirely speculative. That said, quantum entanglement is at least a real and observed phenomenon. We do have a physical base to work from. If ever we do eventually achieve interdimensional travel, though, what would happen next? That moment when humankind first makes any kind of link with another dimension would be a monumental before and after point in history. For one, it would surely herald a new era of maybe even unlimited exploration. It's a reasonable bet that progress would come slowly, and that we wouldn't all be simply opening up portals and leaving this reality behind. Instead, it would unfold in stages. But we may have even already seen the earliest stages, with multiple attempts to genuinely teleport material at the quantum level, including, most notably, by the China National Space Administration. So far, all of that has been happening just in our current dimension, but if there are other, higher directions in which we could go, then some believe that our latest experimentation should alert us to them. Clearly, interdimensional travel in real life would demand massive developments in various fields, from energy production to materials science. Harnessing that ever-elusive exotic matter, manipulating space-time, and controlling quantum phenomena would all push the boundaries of our current knowledge. But all of that would be in search of answers to the most fundamental questions about the nature of existence, like how and why are we here? And is there anywhere else that we could go? Unfortunately, right now, the answer to today's question is quite simple. No, interdimensional travel, beyond the dimensions we already exist in, isn't possible. But, at the same time, and for increasing numbers of theoretical scientists, that's a no, that's just waiting to be proven wrong. They imagine future wormholes, piloting tomorrow's ships fitted with Alcubierre drives, and mastering the quantum realm so completely that we'll one day be able to track and send individual particles en masse to another level entirely.